Hey everyone, welcome to this new video. In the last few videos, I have talked about HTTP virtual hosting and the role of host header in making this possible. Then I also talked about HTTPS virtual hosting concept, where I had shared with you how SNI solves the HTTPS virtual hosting problem, allowing multiple certificates to be served from the same IP address by including the server name in the initial TLS handshake. In this video, I am going to talk about one of the problems that I came across in one of my integration project. In this integration project, the API was provided on virtual host, while the API consumer API client was using the old HTTP library and it was outdated. And because the HTTP library that was being used by this HTTP client, the API client was outdated, it was not able to send the SNI TLS extension during the TLS handshake. This situation is quite normal and people come across this problem quite often, like when they don't support the SNI TLS extension, and there can be many reasons for, so like if the product has not been upgraded for quite a while, maybe 10 years or something, and it is a legacy product that is being used in the IT system, or if the TLS library has not been upgraded for a while, if the HTTP client doesn't support the updated HTTP protocols. So these are some of the common situations in which the client face this issue where they are not able to send the SNI TLS extension. It is quite normal.
So can you share what happens during the TLS handshake if the client doesn't send the SNI TLS extension to the server?
That's a very good question actually. So if you know, in HTTPS virtual hosting, the server is configured to handle several different HTTPS domains, and it presents different SSL certificates to the client depending on the host name or the server name that it receives as SNI during the initial TLS handshake. Now during the TLS handshake, if the client does not send the SNI extension to the server wouldn't know which specific domain on the IP address the client is trying to connect, because I have shared before that in HTTPS virtual hosting, the server handles several different HTTPS domains, right? So now in this situation, when server doesn't receive the SNI extension, it sends its default SSL certificate to the client. Now if you are thinking, what is this default SSL certificate? Actually, this default SSL certificate is configured on the server to be used when server doesn't know which host name the client is trying to reach. I will show you using the SSL Labs example what happens when you don't send the SNI extension to the server and how the behavior is different when you send the SNI extension to the server. So let's see the example. Okay, so let's see what happens when the client does not send the SNI extension to the server using SSL Labs as example. We will use the domain that we had discussed in the previous videos. I will use expire.badssl.com as an example for this video. I'm going to scan it. Okay, now the scan results are out. I want you to show that this server has sent two certificates. Certificate 1, as you can see here. Then if you come down, certificate 2. The other thing that you can note down here is the certificate 2. Against the certificate 2, it is mentioned here no SNI. So when the server didn't receive any SNI from the client, it sent another certificate. As you can see here, the common name of the certificate is mentioned as bad SSL fallback unknown subdomain or no SNI. So whenever the client does not send any SNI, this server returns this certificate, which is completely different. This is the default certificate on this server, and when it sends the SNI, it returned completely different certificate that matches the domain of expired.badssl.com. This is the wildcard certificate wildcard domain certificate installed on this server, so it matched the domain of the expired badssl.com. So with SNI we received this certificate 1. Without SNI we received other certificate, because when you don't send the certificate, when you don't send the SNI, the server doesn't know what domain name or host name the client is trying to reach, so it just sends you the default certificate which is installed on this server. I hope this would have helped you to understand the behavior of the SSL server. So I just showed you how the server can send the default SSL certificate to the client when it doesn't get the SNI from the client. And this can lead to problem for the clients.
Interesting. Why do you believe that this can be a problem?
That's a good question again. The reason this can lead to a problem for the clients is because as part of the TLS handshake, if the client is doing the strict validation, then it must verify that the server certificate matches the requested host name or not, or the URL that you type in the browser, or the API domain that you configure in the HTTP client. So basically, whenever there is such setting, the client verifies whether the server certificate contains the requested host name or not. And in the situation where the server sends the default SSL certificate to the client, it might not contain the host name the client is trying to connect, and that's where it leads to TLS handshake error in certain setups. So to summarize, based on all the videos that I have shared with you, SNI is used to tell the server which domain name the client is trying to connect, and server sends the corresponding certificate to the client. And once the TLS handshake is over and then the HTTP request starts, it is the host header which tells the server which request has to be served and which domain it is trying to connect. Based on that, the request is served to the client. I hope this is clear to you now.